All right, so this is worksheet 25, and this diagram is missing. The area formula for trapezoid is 1/2 the height times the sum of the bases, which can also be written, guys, the average of the bases times the height. It's the same thing. Okay. If we do this, we're trying to find this whole base down here because it asked that question. So this is 10.6. What's this piece right here? And then we need to find that. Yes, it is. So we just have a little tangent question, right? Tangent of 62 equals 8.3 over x. I got 4.2. Did I type something wrong? Oh, it's 62. I typed 63. All right, so if this is 4.4, how long is this whole base down here? All right, so now can you find the area? 1/2 the height times 10.6 plus 15. And again, there's no labels, sorry. Has anybody worked on anything else? Bookwork? On the worksheet? In the book? Page 298. Kate has a question about number 18. I don't really understand this either. But luckily there's a labeled diagram. They want us to find x. Otherwise, I would be kind of clueless what they're talking about either. But this is 28 degrees, and it's across from 25. This is 20 feet, because that's what that little arrow says. I think we have to find this angle up here first. I'm just going to call it A. I don't think we can do anything else. Sine of A is across from 20. The same way sine of 28 is across from 25. I did get 22.1. We did inverse sine. So if we do this, we get 157.9. We already have a 28. Can we have a 157.9? I think it would have a kind of funny looking angle up there. So I think we can ignore that. But we still have to find x. So if this is a 22.1, can we find this angle down here now? 180 minus 22.1 and 28. I got 129.9. Did anybody get that for the angle down here? Now we can do law of sines one more time to find x. I didn't find an easier way to do that, so. This, whatever you get when you do that, is the answer to the whole problem. So. Other questions on the worksheet or the bookwork? Yes. 56, is that in the book as well? Oh, interesting. Okay. 56. A tourist attraction currently has its base connected to a tree platform 150 meters away from a zip line. No, by a zip line. The owners now want to connect the base to a second platform located across the canyon and then connect the platforms to each other. The bearings are on the picture. Okay. This is what we need to know, guys. When we have two parallel lines and we draw a line in between, what do you know about that angle and this angle over here? Not unless it's perpendicular. Yes, because this one is the same as this one, right? And that one is the same as that one. So they add up to 180. So looking at this picture over here, what is this whole angle in this corner? 103. So what's the whole angle in this corner got to be? Okay. Now, when we put this in, this was 39. So 77 minus 39. 38. And this one over here, oh, that was bad, was split 72 and 31. Okay, now can we find this angle up here? (180 minus 38 and 72. I got 70 up there. Anybody else get that? For my crazy drawing? And we know this side is 150. So we need to find both this distance and this distance. Is that better now, Claire? Not Claire. Sorry. No, yes. If they want two separate answers, I guess so. So do we set it up more? Okay. So just law of sine twice. Okay, Basma Wood. Page 298, number 5. Everybody's okay? You're stuck? For angle T? Okay. 180, are you in degrees? Okay. Anytime I get a negative, then I'm worried that I'm in radians. Yes, this is the diagram for 7. I didn't, yeah. It says, here's the hole he's aiming at, and here's the golf ball over here, okay? Currently. Knows he's got a 12-foot putt, but he putts and he misses. Well, that was a bad. Let's try that again. He putts and he misses by 3 degrees in here, okay? The angle from where he wanted to, here at the hole, this angle basically is 129 in here. And he needs to figure out how far he still has to putt back to the hole. My first picture was much better, but Yeah, that whole sentence about the hole now lies at a 129-degree angle between the ball and its spot before the putt. Yeah, that sentence was a little crazy. Do you golf, Aunt Pat? Do you golf? Nope. Did, your brother was a golfer? In the closet, maybe? Oh, is there one under there? No, someone got it. Okay. Yes, I have a couple in the closet. Just they're at the bottom, and it's kind of an avalanche waiting to happen. So don't sue me. Don't sue me if something happens. Okay. Like a disaster down there. The shelves all broke, and so I just like throw everything in there. And I have a picture for 9, if that helps anybody. Anybody stuck on something else yet? All right. Maybe I'll just pause the recording for a minute till someone has questions. That sound like a plan? Because if you go back to worksheet 25, this question 6 is, I don't know, the first time I read it, I didn't understand what it was asking, but it says the area is this, okay? And it's an equilateral triangle with all the sides A. What are the angles on an equilateral triangle? So you could like draw a height in and mess around with that, but I had an epiphany yesterday and decided to try using this. Remember we did this one yesterday? What are the two sides going to be? A and A. And this is going to be the sine of 60. And this is 43.7. Do we know the sine of 60? One half. The sine of 60 is square root of 3 over 2, right? And A times A on a good day is A squared. So if we do some messing around with that, we can solve for A. I don't know if that's the best way to solve, but it worked for me. Morgan, did you end up with any questions on worksheet 26? No? Claire, you doing okay on the book one so far? Sarah? This is a hot mess. Okay, so I'm going to exaggerate the picture a little bit, okay? If this is 21.4, 68.6, okay, thank you, because that makes a 90. This is supposedly making a 90 of the ground here. Up here, we have a 90 plus 18.6, right? And then if you subtract from 180, you get a little 2.8 out there. The issue is we're really trying to find this height. Whoa, clearly that is a straight up and down height on a very windy day. We have to find, oh, and this is 15. I'm thinking we need to find this guy because then we'll know a side for the blue triangle. Okay, you okay? So if you find X, then you'll be able to find the height. Does that seem okay, everybody? The 108.6. I did 90 plus 18.6 because there was a vertical line and then that one is a horizontal plus 18.6. Yeah, that's where I got the 68.6 down in the bottom. Yep. Then there's no triangle that will work. You just say no possible triangle or not possible. Okay? Yeah. Yes, yes. Gotcha. Yeah. I kind of logicked it out first, and then when I did it, it actually came out, and then when I realized it wouldn't work, and it was weird. I don't know. Anybody stuck on one yet? The, this one kind of looks like it might be 132, right? And the bases mean the two that are parallel. So I'm going to go with those two. Isosceles means these are the same. So the area formula, we can still use the one we started the day with for a trapezoid, but we need to find this height. It has a line of symmetry down the middle, so it folds over and matches up. So if this piece in here is 10 from the bottom down there, these two little pieces have to be the same. So 15 minus 10 is 5, so then we have 2.5 and 2.5. Right, then if we do 132 minus 90, this would be 22. Does that seem right? Then we can find the height with that little triangle right there. Oh yeah, 42. I did that earlier today too. You'd think I wouldn't make the same mistake twice, but I would. Anybody else? Is there a picture on your paper or no? Okay. This total distance is 600 feet apart. Does that seem okay? And one of them is looking up 21 and one of them is looking up 19. Here, okay. So if we look at the giant triangle, this is a 140 up here. Does that sound right? So then we need to find like this side and then we'll be able to find the height. You gotta find one of those.